pressure.
Hi, welcome to No Pressure, the talk show where we answer your fluid power questions online. Hi, I'm Jack Weeks for GPM Hydraulic Consulting, the nation's leader in fluid power training, troubleshooting, and reliability. And I'm here by myself today. We're running a skeleton crew because of the coronavirus, but maybe I'll be able to make it. Today we have a customer question that was emailed to us. Let's see here. It says, James Clemmer from Lynn, Missouri here. I have a couple of your manuals, troubleshooting and the manual on leaks. I recently noticed that you have a new No Pressure series on your YouTube channel, so here's a question for No Pressure, and hopefully I won't confuse you too much. Well, James, let's hope not. We'll try to muddle through. The letter goes on to say, we do plastics blow molding. We're turning the screw with a stair motor. Driving the stair are two Vickers piston pumps mounted end to end. I believe they are spec'd at 33 gallons per minute at 3,600 psi. Found that in a book somewhere a long time ago. When the screw needs to turn, the blue valve comes on with full flow. There used to be a proportional valve there, but that broke, and in the time crunch, this is what we got. I can slow the screw speed down by adjusting the bottom screw on the compensator thing, which is a pain. I believe the top adjustment controls pump idle pressure. A proportional valve would be fine, but to me, stroking the pump full blast just to dump some of it off with a proportional valve seems kind of nuts. Is there some kind of valve that will allow me to adjust the pump stroke either remotely or with a knob, or some electrical control that can be connected to the PLC eventually? Thank you, Jimbo. Okay, Jimbo, that's an excellent, multifaceted question. Thank you very much for your contribution to our show. Now, where shall I start? Clearly there was an issue that required you to deviate from the machine design to avoid losing production. Now, this is not usually the best idea, but now I live in the real world, Jimbo, and just speaking from the real world here, we certainly understand that sometimes you just have to do what you have to do. But now it's not a long-term solution. The best advice I can offer you is for you to restore the system to its original design as soon as is practical. Now, let's talk a little bit about why that is. Now, I have no doubt that it's a big pain, as you say, to try to control the speed of that motor by adjusting the pump compensator. I'm actually a little bit surprised not to hear that it's caused some adverse effect on the product. You see, the compensator is not intended for speed control. That was never its purpose. The compensator is used to determine the maximum system pressure. Now, by adjusting it for speed, essentially what you're doing is reducing the system pressure down near the stall pressure of the motor, and doing that to slow it down. Let's talk a little bit about how the compensator actually works. What you have is you have a piston pump, and in a piston pump you have pistons that are mounted in a barrel, not unlike bullets in a revolver. And of course the barrel is turned by the shaft, and the pistons are connected to a swashplate. That's a plate that's being held at an angle by a spring. That spring holds it to the maximum angle, and you see that as the barrel rotates, the angled plate here is going to cause the pistons to stroke. Now, the greater the angle, the farther the piston strokes. The less the angle, the less the pistons stroke. And if you move the swash plate full vertical, the barrel turns, but the pistons don't stroke at all. You go into an idle state. Okay? So, we're not really wasting any flow. The pump's not coming on full blast as it seems. It's swapping up to maximum system pressure, but the flow is reduced to whatever whatever flow maintains that system pressure. Yeah. Okay. Now, that's why it would be best to replace the original proportional valve. Now, I can see how it might appear that the pump is stroking full blast and dumping somewhere in the proportional valve. That's really not what happens there. The proportional valve acts like both a directional valve and a flow control, right? It opens up part way, and it lets just enough flow go through to turn the motor at exactly the speed that we want it to turn. Okay? You could put a flow control in the system. Instead of investing in a new proportional valve, you could keep the valve you got and put a flow control there and adjust the speed manually with the flow control. The only problem with that is that it does require manual intervention. You're going to have to get in there and turn the knob whenever you want to change the speed. Now, with the proportional valve, it's going to shift electronically, and so it will shift as far as the computer tells it to. So that lets the computer determine the speed, exactly changing the speed when we need to exactly what we need. That would have to increase your production, surely enough to pay for the proportional valve. Okay. Now, the final part there, you asked about the valve at the top of the compensator assembly. That's called a load sensing valve, and you are correct. The load sensing valve will determine the idle pressure. When it senses that there's not any load, then that's going to cause the load sensing valve to shift and reduce the system pressure from the setting of the compensator. Right? These are typically factory preset. Usually they're preset between 250 to 400 psi, depending on the pump and the configuration. But as soon as it senses a load, that shifts that load sensing valve so that will hydraulically direct the control of pressure to the compensator away from the load sensing valve. That gives us a higher operating pressure so that we can go to work. Right? So we have a higher operating pressure, a lower idle pressure. By keeping a lower idle pressure, then we don't waste near as much energy while we're idling. So essentially, like I said, my best advice to you, Jimbo, is to put the system back the way it was designed. Get that all adjusted up properly. I'm sure you'll be happy with the result. Thank you very much there, Jimbo. All right, let's see everybody next time. Everybody be safe, stay healthy, and remember, no pressure.
Pressure.